All right, so we're beginning chapters section. We're talking about the normal model and finding probabilities using the normal values for a random variable given normal probability. The normal model, I've highlighted certain parts of this for you to, in the notes for you to see what's happening. The normal model is one of the most widely used probability models for continuous numerical random variables. Notice this is not for discrete, it's for continuous numerical random variable. This is sometimes called a bell curve because of its shape. You may have heard of professors who grade using a bell curve. I do not grade using a bell curve. And here we can see that if we were to graph the heights of adult males, it shows varying heights with a middle height of somewhere around 69 inches. Since it's symmetric and unimodal, it can be modeled using a normal distribution. How does standard deviation affect the shape of the bell curve? If there's a smaller standard deviation, we have a taller curve. There's a larger standard deviation, we have a smaller curve. However, that doesn't change the area under the curves still equal to 1. Now, if we were to compare the heights of men and women, because women are generally not as tall as men, the curves would have the same height, but the spread, the standard deviation is about the same. The mean is different for women and for men than for men, but the standard deviation remains about the same. To talk about some notation here, the Greek symbol mu represents mean of a probability distribution, and sigma represents the standard deviation. The notation end with mu comma sigma in parentheses represents a normal distribution with a mean mu and a standard deviation sigma. It is, I would not say always helpful. It is sometimes helpful to sketch a picture of the area you're interested in finding before using technology to find the area. Most technologies require that you enter the mean and standard deviation of the distribution as well as the beginning and the ending values of the area you're trying to find in the normal model. So I'm going to discuss first how to use the calculator to find the normal model for 64 and 3 for heights of women between 62 and 67, 64 and 3, okay, to get the probability of 0.589. So here we have the sequence that you would type it into the calculator. To do that, you would press second vars and select number 2. Type in your lower 67, 62, your upper is 67, your mean is 64, and the standard deviation is given as 3. Paste it into the format by pressing enter, and you would get your probability is 5.59 or 0.589 or whatever number of decimal places they want you to use. Okay. Let me copy that and place it into the I forgot. It wouldn't do that. Maybe if I made it a little smaller, perhaps I can put it on the side somewhere. Yeah. Yeah, there you go. Okay. Now, how do we use StatCrunch? So research has shown that um, uh, newborn Pacific harbor seals birth length is approximately normal with a mean of 29.5, a standard deviation of 2.5. Find the probability that a randomly selected harbor seal pup is longer, so greater than or equal to 31. To do this with StatCrunch, okay, you want to access your course, press the My Lab and Mastering button, open My Lab and Mastering, select the StatCrunch program on the side. I usually open it in another window in StatCrunch website, open StatCrunch. You can keep it open on your desktop, but we really don't need the rest of these windows open. Okay, so I'm going to close them. And here I would press the Stat button, calculators, normal. Into the mean, I want to enter 29.5. Hold on, not allowing me to type here. See if that works. Okay, 29.5 and a standard deviation of 2.5, less than 31. Compute. So this is my graph. And you can see the probability is 0.7257. Okay. 0.7. Oh, I'm sorry. It's greater than. My bad. Greater than, not less than. All right. So go back to this and fix what I did wrong here. Change it to greater than 31. Probability is 2.7423. Okay. So right there, probability is 2.7422. Now, if you're putting this in the calculator, the process is a little different. Okay. So if we went to the calculator to do the same problem, second vars number 2, I would type in 31, and then the upper limit goes up to a really large number, right? Because it's to the right. 29.5 and 2.5. And I would get the same probability, 0.2742. I copied and paste that in so you can see the data for it. So whatever makes you happy. If you want to do the calculator or StatCrunch, it's up to you. I don't use the normal table a lot. I'm going to probably explain a bit of it when we get to the problems, but I don't use that a whole lot. They're cumbersome and they take a long time, and I kind of have very little patience. Now, how do we go backwards? If you're finding X value is given a probability, sometimes we're interested in finding the value for random variables associated with a given probability. Take, for example, birth lengths of newborn seal pups follow the model 29.5 and 1.2. Suppose those pups with lengths of 15% percentile and below are unlikely to survive. So we would convert that 15 percentile to 0.15 as a percentage and use the StatCrunch program to plug in the numbers. Now, I wanted to just show you how you would work backwards on that. Here we go. We can open the calculator, sorry, the StatCrunch program. 29.5, 2.5. Sorry, this is now 1.2, right? 1.2. And we have, they're giving us, so right here is blank, okay? They're giving us the probability is 15 percentile, 0.15. And compute, and you're getting 30.7434. So I must have had some number wrong here. What do you think? Oh, that's because I'm taking greater than, it's less than. Yeah, but something is wrong. There's a wrong number here. Let's type that in again. 0.15. Okay, now it's correct. So I typed in the 1.5 and it spit out the X value as 28.2562. I'm sorry, I keep forgetting this thing doesn't paste on top of another image. So you can paste it on the side here, yeah. Okay. In the TI-84, it's a little different because here you would select, so stay with me here, second vars, and you would, what did I do? Second distribution, and select number 3. The area is 0.15, mean is 29.5, standard deviation is 1.2, and it's less than, so it's to the left, and you'd get about the same answer that you got with the StatCrunch program. Yeah. How do you determine if it's normal or inverse? So you want to look. It is known that the heights of adult men follow a normal model. For each of the following situations, decide if it is normal or inverse. The clothing manager wonders what percentage of her customers are taller than 6 feet. The clothing manager wants to cater to the tallest of the 20% of men. Okay, so here we have a percentile. That's your clue right there that is inverse. Okay, you're given a percentile, inverse, normal. If the percentile is not given, then we're talking about regular normal program, not an inverse normal. All right, here we go. So some problems here from the homework. I'm going to try to make this a little bigger. Okay, this uses the traditional symmetric empirical rule. Remember, the empirical rule is 65 for one standard deviation, 65%, 95% for two standard deviations. And over 2 standard deviations is almost all. In the first instance, it's just testing your general knowledge of this. It's asking about what percentage is between -2 and 2. 2 standard deviations is 95%. Between -3 and +3, almost all, and you can get that from the picture. Between 1 standard deviation, 68%. Roughly more than 0, everything to the right of 0 is 50% of the graph. And between 1 and 2 is 95 minus 68, and we have to divide it by 2 because it's on one side only. Very straightforward questions. In the next question, we have the quantitative score on a test approximately normal distributed with a mean of 500 and a standard deviation of 100 on the horizontal axis indicate the correct scores, which provide these scores, and answer the question using your knowledge of the empirical rule and symmetry. So this is obviously graph C, because graph C shows the mean as 500 and then the standard deviations of 100 to the left and 100 to the right. That's the only graph that actually shows that. Okay? And then we answer the questions. So everything to the right of the 500, the 0 point, everything to the right of 500 is 50% of our graph. Between 400 and 600 is 1 standard deviation, 68%. More than 800 is greater and above all, so it's about 0%. And less than 200 is also in the almost all region, about 0%. Between 300 and 700 is 2 standard deviations, or 95%. And then between 95 to 100 is where we have 700 to 800. But 95 to 100 is both sides of the graph. We have to divide that number by 2. So it's 5 divided by 2, or 2.5%, to get to what we want in terms of the correct number. The next problem, question 3, represents a printout from the StatCrunch program, and they're asking you to identify the correct graph. I think I smudged this just a little bit, okay? To identify the correct graph. So looking at the numbers here, the mean and standard deviation are the same on both graphs. And they're saying with an IQ of 100 or above, 105 or above, so the shading would be to the right, which makes it the first graph. And you can see in the little box the probability is 0.3694. I use technology in this to get the graph. When you're not given the mean and the standard deviation, you take them as 0 and 1, and everything to the left of 0.079. I can show you real quickly how I did that. So I put the mean as 0, the standard deviation is 1, and everything less than 0.79 and the graph. Okay, notice the probability is 0.7852. Then if they're asking about to the right, so all I would do now is go back to my StatCrunch program and flip the sign to the greater than, and notice this is 0.2147. I copied and pasted that into the notes for you. Okay. Something to notice is that if you understand the graphs already, then and you got the first probability, then to get the second probability, all you would have to do is subtract uh, the first probability from 1 to get the second number, which is down here on the program. You wouldn't need to go through the whole process. In other words, if you understood the graph, all you would need to do is calculate one of the probabilities, and the program would do, you're able to do the rest of it without stressing out too much. All right, here we go. So this one here, a similar type of problem, wanting us to find, use the table. I didn't use the table for this. Find the area of negative 1.55. I simply went to the calculator. I'm sorry, the StatCrunch program, typed in negative 1.55 less than, and I got my probability is 0.0606. And then if you flip the sign around to greater than, you get 0.9394. Again, if you kind of getting the picture on the graph, less than would be here, greater than would be the outer shaded region to the right hand side. You would just need to subtract the two. If you got one of the probabilities, all you would need to do is subtract the two numbers to get the second probability. All right, so this problem, I started to graph it here, and I kind of put some numbers on it. Let me see if I can move this for a second. I'm not sure where the mouse went to. Okay, so mouse keep doing the disappearing act on me. All right, so in this case, things not behaving here. I went to the calculator for number 6. I put in the mean and standard deviation as 0 and 1, and then it asked me about less than, which is this graph D is the only one that shows less than, but I needed the program to tell me the standard deviation right here. Sorry, the probability. And then greater than, I put it into the calculator. I got the second graph for this one, which is, and you got the number from StatCrunch already, but you can subtract 0.7454 from 1 and get the number. Now, the third part of this problem is where you have to pay a little bit of attention, because here we have between negative 1.6 and negative 1.06. So to do this, we would need first to compute the probability of less than 1.06 and less than 1.6 and subtract the two. So let's do that. Negative 1.06 less than, I'm going to copy this and paste it over. And then we need the second one, which is less than 1.6. Negative 1.6, my bad. Compute. We get 0.0547. So now I want to go ahead and subtract these two numbers. Subtract the two numbers. I need to write, so I'm going to close this for a second. This is 0.1446 minus 0.0548. Okay, and at this point you would use a calculator to subtract the two areas. 0.1446 minus 0.0548, which is 0.098. 898. Okay. All right, let's move on. For this is all for questions. Up to here is for question 6. Let's look at question 7. I'm not sure why this thing is doing this. Find the area to the right of z equals to 5. Okay, using 0 and 1 as the probability. So if the z is 5, this would be to the right would be this graph. Okay, graph A. I don't think you need to graph that, do you? And to the right of 10, which one would show to the right of 10 here? To the right of 10 would be graph B. All right, the right of 10 would be graph B. There's nothing on the left shaded, everything to the right. Okay. And then it's just find the area to the right of 50. I hope you can see where this is going. I'm not even putting this in a program. To the right of 50 would be this graph right here, right of 50. Notice we can't use A because A is shaded to the left. If you had exactly, now look at question D. If you had the exact probability for these tall proportions would be the biggest, which would be the biggest and which would be the smallest? So if you had the exact probability for these tall proportions, which would be the biggest and which would be the tallest? To me, it seems obvious that the tallest would be z is equal to 5 and the shortest would be z is equal to 50. Right? 5 and 50 would be the smallest. Remember what we said about how much further you go to the right. And probability represents the area on the curve. So the area to the right of 50 would be very small. And then part E, which is equal to the area in part B. To the left of Z is greater than, this is this graph here. to the left of Z is below Z is -10, and to the right or above Z to the right, which they're asking which is equal area in part B. So it's obvious that the area below Z is equal to -10 is equal to the area in part B. In other words, below would be this one right here, that one, below or to the left. These two graphs have approximately the same area. Question 9. Oh, wait, I skipped over question 8. Assume that adults have IQ scores that are normally distributed with a mean of 105 and a standard deviation of 15. Find the probability of less than 120. We can do this real quickly with our calculator, yeah? Let me write those numbers down. This is mean is 105, standard deviation is 15, less than 120. Okay, so go to your calculator. Now you want the upper to be a really small, the lower to be a really small number, so 0.9999. The upper is 120. The mean is 105. The standard deviation is 15. And you get 0.8413. Okay, 0.8413. I'm going to put it on the side here so you can see it, hopefully. So this is 0.8413. Alternatively, you can use StatCrunch and do the same by opening the StatCrunch program, typing in the mean as 105. The standard deviation as 2.15. And less than 120. I'm not even sure if I'm on the right problem here. Yeah, let's see. Less than 120. Yeah, that's the correct problem. And get the answer as well using the program, yeah? So more than one ways to get your answer for this. Whatever makes you happy, you can, again, use the StatCrunch program to also get your answer for this. I'll paste that StatCrunch program. All right, moving right along. So according to a recent study The average length of a newborn baby is 18.3 inches, standard deviation 1 inch. The distribution is approximately normal, so 18.3, 1. What is the probability the baby will have a length of 19.3 or above? Okay, so again, you can likely pick out the graph, but then you can't find the probability without using your program, right? Right there, you can pick out your graph as graph D to the right of 19.3, which is approximately 1 standard deviation. And let's see, you can probably, how do you want to do this? We can use StatCrunch, or we can use a calculator. Let's do the calculator for this one. No, we're going to go ahead and use the StatCrunch program. That's much friendlier. Okay, so mean is, oh, this thing is cumbersome to type. Mean is 18.3. Standard deviation is 1. So we just actually need to go back 1 decimal place here. And greater than 19.3. We flip the sign around to greater than, compute, and we get the probability is 0.1587. I'm sorry, to 3 decimal places, 0.159. Okay, so 0.159. I'm going to paste that on the side for you in a second. Probability 20.3 or more for the next part of the question. So $20.3. It's again 20.3 or more. So I would go with this curve right here to the right of 2 standard deviation, 20.3 or more. Okay. Let's type in 20.3 here into the program. And we get the probability is 0.023. And then in between 2 would obviously be this graph. To compute this, you want to go perhaps everything to the right of 17.4 and then everything to the right of 19.2 and subtract the 2. Okay, so everything to the right of 17.4 and everything to the right of 19.2 and subtract the two numbers. And 8159. 0.8159, and then the second number is 19.2 is 0.184. 0.184. So you would go ahead and write those two numbers down and subtract them. That would be 0.8159 minus, what was that number? 0.184. Calculator, they want the answer to 3 decimal places. So this is 0.8159 minus 0.184, which is approximately 0.632. Okay. All right, moving on. Question 10. In a certain state, the average critical reading standardized test was 533. Assume that the standard deviation is 50 and that the standardized test scores are normally distributed. What percentage of the standardized test takers scored 500%, 500 or less? So that's about 500 or less is less than between 0 and 1 standard deviation. I would say that that's graph C. Okay, you can put that into the StatCrunch program as mean is 533, standard deviation 50, 500 or less. Let's go ahead and put that into our StatCrunch program really quickly. Mean is 533, standard deviation is 50, less than 500, and that would give you your I think one of my numbers might be incorrect. What are they asking for? Oh, they want it as a percentage. Okay. Copy. Okay, so as a percentage, it will be what? 25.5? Yeah, 25.5%. Okay, we take this 25.5 multiplied by 100, we get 25.46. Okay, when you multiply by 100 to convert it to percent. The second question, part of the question, what percent is less than 533? Less than 533. So 533 is the mean, isn't it? Okay, so right there, because the mean is 50%. Less than 533 is the halfway point. All right, number 11, a city's mean minimum daily temperature is 26. Suppose the standard deviation is for February is 3%. This is number 11. And the distribution is approximately normal. What percentage of days in February has a minimum freezing temperature of 32 degrees Fahrenheit? You can do this with the calculator or with StatCrunch. Again, whichever one makes you happy. The mean is 26. Standard deviation is 3. Below freezing, so below 32. Let's see, I can go to the StatCrunch program first. So mean is 26. Standard deviation is 3. Below 32 compute, and I get 0.977, which is approximately 98%. Okay. Oh, that's not the right image. Okay, approximately 98%, 9777 times 100. You can also do this problem with your calculator by selecting normal CDF number 2. So the lower would be a really small number, the upper would be 32, the mean would be 26, standard deviation 2. Enter, 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 and get the same, approximately the same answers, 0.998, or approximately, I think one of my numbers might have been incorrect here. Let me look again. Yeah, one of my numbers appear to be incorrect. Let me go back and check that. 26, 3, not 2. There's always an explanation, right? Yeah. Go back here, distribution, small number. I think the only thing we needed to change here is just to 3 here. And that gives us 98%, times 100 would give you 97.7, which is 98%. Okay? All right, moving on. Question 12, the normal model 65 2.5 describes the distribution of heights of college women. Which of the following questions ask for a probability, which asks for measurement, and is thus an inverse normal? So first of all, they're asking which one of the questions imply an inverse normal. Remember, the inverse normal will have a percentage. Okay, so right there, that one, B would be the inverse, and A would be normal probability. 13, in a standard distribution model, if the area to the left of the z-score is 0.15, what is the approximate z-score? Draw a sketch of the answer to the left. If we think about this, to the left would be a graph right here, to the left of 0, which is negative 1.55. Oh, I'm sorry, slightly less than 0, which is 0.15. Yeah. The z-score, we would have to do an inverse norm to find a z-score. Okay. Or you can use the table. The table is really cumbersome, but I can show you how to do the inverse norm for it. Okay. So I've got 1.5. So I'm going to go to StatCrunch. 0, 1. Type in 1.15 here and compute. So this gives me negative 1.36 as the solution, as the z-score, because I used the inverse norm. Okay. Negative 1.36 to how many decimal? To 2 decimal place is negative 1.04. Alternatively, you can use the calculator. To use the calculator for this, I would go to my calculator, second distribution, select number 3 for inverse norm, type in the areas 0.15, mean is 0, standard deviation. It's a less than, so the tail is on the left. And get your answer is negative. Let me do this and clear it up again. Second distribution, so I can copy this screen for you, right? Inverse norm, enter, 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 enter. And you get exactly the same answers if you were doing this in StatCrunch, yeah? So 2 ways to get the answer for this question. Question 15, a study of population showed the male body temperatures approximately normally distributed with a mean of 98.1 and a standard deviation of 0.7. What body temperature does a male have if it's in the 83rd percentile? So we need a body temperature here. And of course, the correct graph, we can probably pick out the graph before anything because we're talking about something that's slightly to the right of the mean, which is graph C. But now let's not take that for granted. Let's go ahead and put this into the StatCrunch program and see what we get, yeah? So StatCrunch, the mean is 98.1, standard deviation is 0.70, and they're giving us 83rd percentile, so 0.83. And we see that normal body temperature is around 98.76. Okay, right there. To 1 decimal place, 98.8 degrees Fahrenheit. And now it's easy to see that the graph is graph C, yes? If you wanted to do this problem with your calculator, you would do inverse norm. Type in 0.83 as the percentile, 98.1 as the mean, and the standard deviation is 0.7. Enter, enter, and you get it as 98.8. Okay. All right, the last two questions. What is the most widely used? It's obviously a normal distribution. And what determines the exact shape of the normal distribution? Recall from the note that the values of the mean and the standard deviation would do that. This is normal distribution. Okay, this was a long lesson, but we're done. So, yay.